Tingnan mo.
Ayan. Okay, recording na. Ayan, feeling ko tuloy parang sinipon ako. Anyway, nahawa lang pala, no? So, last meeting, we discussed the intermolecular forces of attraction, but this time, it's more on the examples are more concentrated or more focused on organic compounds. So, as we can see here, we have the different intermolecular forces of attraction. Let's say we have the VDW, but this VDW is also known as what, Josh? It's more what? Specifically, ito ay yung para sa mga non-polar molecules.
Hmm,
Anong specific VDW yon?
London dispersion for you.
Very good. So the London dispersion forces. So it's actually the weakest na intermolecular forces of attraction, and this one is exhibited by all molecules. So regardless kung non-polar ka or polar or can do hydrogen bonding, this can be exhibited by all molecules. So, ngayon, ang VDW or the London Dispersion Forces is the main force or the dominant IMFA for non-polar compounds. So, let's say you have a non-polar such as, ang given dito ay pentane. So, yeah, 1, 2, 3, 4, 5, pentane. So, if you have two pentane molecules, they can interact with one another via London dispersion forces. But the London dispersion forces is a weak force, so therefore, mabilis siyang ma-break, no? So, ngayon, very important to just siya yung presence ng London dispersion forces kasi this will also explain why we can liquefy gases. 'Di ba? Ang propane mo, ilang example, ang propane, Josh, ilang carbon yon?
Look,
Tatlo. So, ito, kunwari yung propane, no? So,
tingnan mo pa.
ang propane in a natural sense, it's a gas, no? So, CH3, CH2, CH3, that's propane. So, gas talaga siya, Josh, no? So, sa natural condition. But, since gas ito, no, kung wala talagang interaction yung mga non-polar molecules such as propane, we cannot liquefy them. But we know that propane can be liquefied, and it's actually the major component for liquefied petroleum gas, no? So,
Wala mo.
karamihan ng LPG mo, ang laman diyan ay propane. Yes, go ahead.
Kung ano po pala, kung wala po talagang, there are no interactions between gases, between any molecules. They will
Mhm.
forever exist.
Yeah, ideally dapat kasi hindi
Hindi
sila nag-interact eh. Kaya nga ano siya eh, yung kinetic molecular theory, good yan for gases na nasa mataas na temperature and mababang
kaya
pressure, 'di ba?
ideal. Yung,
Yeah, ideal gas, good. So ang mga ideal gas, hindi talaga sila nagle-liquefy. But of course, gases present in our nature, it's not ideal, no? They're called what again?
yung
Kunwari,
gases
yung
po.
propane gas. Real gases yan. And in real gases, we are considering the interaction between the molecules. No? So we're counting the effects of, let's say, van der Waals forces for your gas molecules. So ang mahalaga dito, Josh, non-polar ay mga BDW. That's your weakest na IMF. Then we have now sa mga organic compounds, we have polar molecules such as aldehyde, ketone, alcohols, mga polar molecule kasi yun, no? So these molecules, carboxylic acids, the carbonyl group, then the carboxylic acid derivatives, those will be dipole molecules as well. So we can have dipole-dipole interaction. It's a moderately strong intermolecular force of attraction. But a special case of dipole-dipole is what? May special case yung dipole-dipole eh. Dapat yung hydrogen mo nakabond sa isang electronegative element such as oxygen, nitrogen, fluorine, or even chlorine. And that one will give you a strong, relatively strong IMFA, and it's known as hydrogen bonding. So please take note, Joshua, ang hydrogen bonding ay special case lang ni dipole-dipole interaction. Kasi nga, nagkataon dito, si hydrogen mo, nakabond siya sa highly electronegative element. And then, of course, if you have ion, so that will give you ion-ion interaction. So this interaction exists in ionic compounds such as sodium chloride, lithium chloride, etc. So ngayon, by virtue of physical properties, we can now have or we can predict, no, the physical properties of organic compounds. So the first one, we're done with this one, no, boiling point, no. So sa boiling point, Josh, we're already done with this one. Ang kailangan mo dito is kung boiling point is the temperature at which the atmospheric pressure is equal to the vapor pressure of your solution or of your substance, di ba? So, ano lang yung dito, ginawang practical yung definition dito kasi organic chemistry nga. So, eto ngayon yung trend, Josh, the higher or the stronger the intermolecular forces, it means the molecules are being held together. So that means that you'll have a higher boiling point or a higher temperature is required so that you can convert your liquid organic compounds into gaseous organic compounds, no? Ngayon, pag nagko-compare ka, make sure, Josh, kapag nagko-compare ka, i-approximate mo muna yung mga molecular weight nila. Kung sino yung magkakabigat or kung sino yung magkakalapit yung molar masses, sila yung pwede mong i-compare directly. So, syempre, kapag lumalaki kasi yung molecular weight, ibig sabihin nun, lumalaki din yung molecule, Josh. So, there's another factor you need to consider for that. So, pag ganito same molecular weight, ang pinaka mababang boiling point, yung mga organic compounds with VDW lang. Then, yung nasa mid-range will be the dipole-dipole, and compounds with hydrogen bonding will be the strongest one, no? So, ito yung binigay nating example nung last time, no? So, pentane, butanol, and butanol. Pentane is just BDW, butanol is dipole-dipole interaction, while butanol can perform hydrogen bonding. Thus, butanol will have the highest boiling point among the three compounds. So, we also have this comparison na kapag mas malaki yung ngayon, yun kasi yung binigay kong kaninang rule, we are assuming there that the molar masses are quite same, no? So, yun yung gagamitin mo kapag pare-pares. Paano kapag mas by size na? So, ngayon, kung mataas ang molar mass or molecular weight, we are assuming there that the molecule is large. So, it means if the molecule is large, it will also have a larger surface area. And a larger surface area means you'll have a higher boiling point because larger surface area, more interaction with your molecules. Kaya dapat mas malaki yung or mas mataas yung boiling point na ipipredict natin dun sa mga molecule na yan. So we can clearly see here that the acetone will have a lower boiling point compared to your 3-pentanone because 3-pentanone is larger than acetone. We also have this trend, no, the polarizability. So sa polarizability, Josh, no, the more polarizable the atoms, the higher the boiling point. So what can you say about polarizable atoms, Josh? Larger or smaller? Kailan nga mas polarizable ang atoms, Josh? Larger or smaller? Do you recall?
No. Yung basta yung ano po, yung polar yung mga electronegative mga
Hindi.
atoms.
Kailan magiging polarizable ang atoms? Larger
Wala.
atoms or smaller atoms?
Smaller.
Why? Bakit mas polarizable yung mga smaller atoms?
Wait lang mo. Mas ano yung, mas maraming, kumbaga mas acidic yung ano. Yung mga,
O,
so,
ano
mas,
muna yung polarizability para mag-guide ka? What is polarizability?
yung, yung,
Polarizability is the ability of atoms to be affected easily by electronic environment. So, kailan ka mabilis maapektuhan ng environment mo? Yung electronic cloud.
higher surface
Mas
area.
malaki or mas maliit?
Mas malaki mo. Higher, yung ano, tawag doon,
Larger or
higher,
smaller atoms?
larger atoms po, higher
Very
surface.
good. Larger atoms tend to be more polarizable than smaller ones. So therefore, kasi nga malaki masyado yung electronic cloud distribution nila eh. So they can be easily affected by changes in their electronic environment. So therefore, pag ganon, Josh, the more polarizable the atoms, it will also equate to higher boiling point because it you'll have a larger volume nga ng atom, a larger volume ng atom such as iodide versus fluorine, no, or fluoride. So we have iodomate methane versus fluoromethane. So there's drastic, no, very drastic change from when comparing fluoromethane and iodomethane. Fluoromethane, which contains fluorine, a very small atom, very small ha, ang fluorine, Josh, one of the smallest atoms yan, ay ang boiling point niya, -78 degrees Celsius. Kasi nga, hindi rin siya ganun ka-polarizable, no? Or less polarizable. While iodine, which is near sa bottom no ng halogens natin, since your iodide or your iodine atom has a larger size, it's more polarizable compared to your fluorine, no? So therefore, it will also have higher boiling point. And if we will compare the two, tingnan mo ang fluoromethane, Josh, -78 degrees Celsius. While the boiling point of iodomethane is 42 degrees Celsius. So, ang laking difference yan. 42 tsaka -78, no? So, 22, 64. Ang laki ng range noon. 64 degrees Celsius ang range ng or difference ng fluoromethane and iodomethane. So, we can clearly see there that polarizability will really affect the boiling point. Okay? So, this is the usual setup for boiling point. We've discussed this already. Tapos dito tayo nag-end, no? So, eto tama mo to lahat eh. Congratulations, no? You're good with predicting sino yung may mas mataas or mababang boiling point. So, for today, Josh, mukhang matatapos natin lahat ng topic natin today. So, try nating tapusin. So, the first one is melting point. So, the second one will be melting point. So, what is melting point? So, melting point is just a temperature at which a solid is converted to its liquid phase. Vice versa dapat ito. So, like what I mentioned, no, yung nandito sa presentation kasi, ginagawa niyang practical yung definition ng melting point and boiling point kasi yun yung nakikita natin sa laboratory. So, anyway, melting point and freezing point, they're just the same, no? This is the temperature at which their solid and liquid states are in equilibrium. So, yun talaga yung pinaka-meaning ni melting point. So, in melting, there's an energy needed to overcome the attractive forces in the more ordered crystalline solid. Since we're dealing with the melting point, no, we're converting solid into liquid. So, if that is the case, Josh, you will need more energy. So, endothermic ngayon ang melting, no? So, papasok ka, mag-input ka ng energy para ma-break yung mga intermolecular forces of attraction. And then, from your ordered solid, tapos magiging liquid siya. So the stronger, ganun pa rin yung trend, no? Like boiling point, the stronger the intermolecular forces of attraction, the molecules will have, the higher the melting point. So sino-sino ba yung mga intermolecular forces of attraction mo? Yun yung na-review natin kanina, no? So ganun pa rin yung technique dito or yung ano dito, Josh, strategy. Tingnan mo muna kung ano yung mga organic molecules. You look for your organic molecules, identify their functional groups, and then their functional groups will decide what intermolecular forces of attraction will your molecules have, no? So once you know kasi the intermolecular forces of attraction na kung ano yung meron yung molecule, you can easily predict the boiling point and melting point of your organic compounds. Okay? So, ayan na siya. So, same thing dito. Given the same functional group, the more, there's an additional, ano pala dyan siya, there's an additional rule here aside dun sa na kaparehas ni boiling point. Dahil melting point ito, Josh, melting point or freezing point, no? Paano kapag nag-freeze siya or from melting, no? So solid form, paano yung effect ng symmetry? Meron 'yan. So given
Ah,
the same functional group, kasi 'di ba
so,
nagiging ordered 'yan eh.
mas maganda po yung,
Nag-ordered. Hmm.
para mas maganda po yung shape niya, mas madali po mag-form ng lattice. Parang ganun
Yeah.
po.
Given the same functional group, the more symmetrical the compound, the higher the melting point. Why? Because you can easily stack them. Example lang. May example naman dyan dito. Ayan. Dito na
Carbon
lang.
dioxide.
Ito, kunwari ito, Josh. 1, 2, 3. 1, 2, 3,
Bakit
4.
po yung carbon dioxide po mas ano po yung melting point na sa tubig?
Hmm?
Ay,
Yung
yung carbon dioxide po mas ano siya sa CS2.
mas soluble?
Mas ano po siya, mas mababa yung freezing point.
Freezing points kaysa sa CS2.
Opo.
CS2. CO2, carbon dioxide. Sige, predict natin. CO2.
Mababa yung freezing.
Polarizability to. Sino mas
Ah,
mababa ang boiling point?
si carbon dioxide.
Mas maliit kasi siya. Si CS2
Ah,
mas malaki yan eh. 'Di ba? The larger the atoms, the more sites for interaction. So CS2 will have the higher melting point, no? Compared to your carbon dioxide. Okay? Kaya katulad nito, no? Ito, bigyan kita ng example. Kasi kailangan mo dito, ang mangyayari ay may effect yung symmetry, no? Compared to your boiling point. Try nga natin to. Ko-confirm ko lang.
di ba po yung neopentate para mas mata sa baba? Freezing point. Ano po yata siya eh, gas po siya, di ba? Pag,
Yan, hinahanap ko. That is okay, isobutane. Negative 160. Mas ano pa rin to. Kasi nga ano to eh, smaller na habaan natin. Yun. Yan. Versus 1, 2, 3, 4, 5. Ayan, eto. Ayan. Tignan mo to, Josh. Anong longest chain dito? Sige, para at least medyo start lang tayo sa alkanes din. Dito sa compounds, Josh. What is your longest chain here? Sige nga. Can you name the longest chain for each compound, Josh?
yung isa si pentate.
Hanggang
Pentate?
pentane. Pentane, correct. 5, no? So, pero yung isa, let's say, lalagyan ko ng number. 1, 2, 3, 4, 5. Nasaan ang methyl group mo sa first one? Nasaan ang methyl group, Josh? Sa first.
2 siya. 2 methyl
Carbon
pentate.
2. Kaya ang tawag dito ay 2-methyl pentane. Good.
Yung isa naman, methyl pentate.
Okay, may tanong ako. Which one will have a higher boiling point? Melting point, rather. Tingin mo.
Higher melting point mo?
Yeah, higher melting point.
Di
Relatively, same sila ng molar mass niya kasi isomers siyang mga yun.
2
Constitutional
methyl
isomers.
pentate.
Sino mas mataas again ang melting point?
2 methyl pentate?
Why 2-methyl pentane? Why do you think so?
Symmetrical po siya eh.
Yung 2-methyl pentane? Symmetrical?
Asymmetrical po siya.
Okay. Kung asymmetrical siya, mas mataas ba yung ano niya? Melting point?
So, mababa siya. So, mas
Correct.
mataas. Kahit na gano'n lang po kaliit na yung change. Kung let's say po,
Yes,
heptane,
meron yan.
heptane po, 3 saka 7.
So, ito symmetrical kasi. So this is highly symmetrical and this is asymmetrical. So ito, lower melting point, we expect that the 3-methyl pentane will have higher melting point because you can easily form crystal structure for symmetrical compound. Just ganito yung rule dyan. Pag nag-stack kasi sila, imaginein mo ha, pag nag-stack yung 2-methyl pentane, hindi maganda yung stacking nila kasi hindi symmetrical or pag nagki-crystallize rather, no. Upon crystallization, asymmetric organic compounds will have harder time to form a crystal lattice because asymmetric nga sila. Pero kapag symmetric ang organic compounds mo, Josh, they can easily form crystal lattices. So if they can easily form crystal lattices, mas stable ngayon yung crystal lattice. So, it means more energy yung kailangan mong baliin or more energy ang needed mo so that you can abrupt no the or disrupt rather, you can disrupt the binding or the intermolecular forces between molecules, no, pag mga symmetrical na compounds. So, ito yung example natin diyan. So for covalent molecules, first rule pa rin, having the same molecular weight, the melting point depends upon the identity of the functional group and the intermolecular attraction that bears it. So, kunwari compounds with small or weak van der Waals forces, sila ang may pinakamaliit na melting point, followed by compounds with dipole-dipole interaction kasi intermediate yan na strength na IMFA. And then compounds with hydrogen bonding. Sila ngayon ang may mataas na melting point. No? So ito yung sinasabi ko kanina sa iyo. Let's say ayan, isopentane and neopentane. So ito another example na naman, no. So for compounds having the same functional group and similar molecular weights, the more compact and symmetrical the shape, the higher the melting point. A compact symmetrical molecule kasi, Josh, like neopentane, packs well or packs easily into a crystalline lattice, whereas isopentane does not. So neopentane, therefore, will have a much higher melting point than isopentane. So, tignan mo tong isopentane, Josh. Sige nga, what's the name of this? Try mong pangalanan nito, Josh. Ayan.
Pentane. That's neopentane. Tapos yung isa is, for,
Ano
3,
again? Paano itong isopentane?
3-methyl butane.
Mali. Atong isopentane, ang pangalan niyan ay 1, 2, 3, 4. So, 2-methyl butane. How about yung neopentane? Ano niya? IUPAC name, Josh? Isopentane and neopentane are common names kasi. Sige, ano ang longest chain mo sa neopentane? Sige nga. Ayan, para at least nakakapag-start tayo sa alkanes. Parang ano to, no? Previous sa alkanes.
So,
What's your longest chain, Josh?
butane.
Sa neopentane. Again, ano?
Ano na lang po? Ano ba? Propane? Tapos may ano?
Correct, propane lang. Pero, at carbon 2, ilang methyl ang nakakabit? At carbon 2, Josh, ilang methyl group ang nakakabit?
Dalawa.
Dalawa. So, ang pangalan nito ay 2,2-dimethyl-propane. 2,2-dimethyl-propane. So, that is the name of your compound. Okay? So, ayan. So, with that, you can now predict, no? Predict which compound in each pair has the higher melting point. Sige, go ahead. Almost the same din naman yan sa boiling point natin. So, tatlo lang siya. Bilugan mo lang, Josh, ha? So, bigyan lang kita 1 minute for this. Bilugan mo lang kung sino yung mas mataas yung boiling point. Melting point rather.
So, mas mataas yung ano.
Yan. Predict which compound in each pair has the higher melting point.
Polar pala to. Yan mo.
Okay, wait lang. Double check your answers. Final answer na, Josh? Is that your final answer? You can try to double check your answer. Okay, sige. Mukhang ayan na. Final ka na sa mga sagot mo. Josh, sa letter A, which one will have a higher boiling point? Of course, this is pentane and this is butylamine. The answer is correct, no? Kasi ang butylamine can do hydrogen bonding. Samantalang yung isa, VDW lang, no? Or London dispersion forces. So pentane can only the dominant force for or intermolecular force of attraction for pentane is LDF. While for butylamine, may hydrogen bonding ka. How about sa letter B? Sige nga, Josh, can you give me what is your reasoning behind that? Try mo pala muna din hanapin yung longest chain for the left compound. Sa left
Longest.
compound mo, Josh, what's your longest chain?
Si pentane.
Again?
Kasi
Letter B tayo, letter B. Anong
propane.
longest chain mo?
Propane. Tapos
Again?
yung dalawa.
Okay.
Propane. Tapos yung
Hindi
dalawa pa methyl.
propane yan, ha? Bilangin mo. Ilang carbon yan?
Butane.
Butane. Good. So, butane.
Okay.
And then you have, kung lalagyan natin ng, ano no, numbering 1, 2, 3, 4. Nasaan ang mga branches mo or substituents, no? Kung na tinatawag. Nasa mga number, Josh? Nasa mga
Ah,
number, Josh? Nasa number 2 at number 3, right?
abo.
So, magiging 2, 2, 3, 3. So, ilan ngayon yung methyl group na nakakabit sa kanya? 2, 2, 3, 3. What? Ilang methyl groups lahat-lahat ang nakikita mo, Josh? Dun sa longest chain mo.
Longest chain. Si, ano po, so,
Dalawa sa
kung
number 2.
dalawa sa number 2, dalawa sa number 3.
So, ilan lahat ng methyl group?
Apat.
So, anong ano nun? Anong name nun?
2, 2, 3, 3, methyl,
Tetra.
tetramethyl, tetramethyl butane.
Correct. Kasi apat siya. Tetramethyl butane. Very good. How about dun sa right compound? Which one is ano? The longest chain. Madali naman ma-identify yung longest chain dito, no? Ito. 1. Anong bilang? Or anong longest chain mo, Josh? For the left compound. Right compound rather. Letter B, right compound. What's your longest chain? Yes, Josh, anong longest chain mo sa letter B?
Ah, 1,
Letter
2, 3.
B, right compound. Very good, 7, no? Heptane to. Pero sa number 3 mo, meron kang methyl group. So, 3-methyl heptane. So, may tanong ako dito, Josh. Bakit sa letter B, yung left compound mo, yung mas mataas yung melting point? Bakit? Why? Why did you answer in letter B that the left compound has a higher melting point than the right compound?
Di ba po ma-outweigh ng symmetry na yung ano?
Very good, tama. Symmetry to, no? So this is more
Ma-outweigh na po yung palaki ng isa eh.
correct. This is more symmetrical and we know that kasi nga sa melting point, yun ang difference ng boiling point at melting point, Josh, ha? Ang melting point kasi, Josh, gumagawa ng crystalline solid. So kapag symmetrical yung organic compound, madaling mag-stack, no? Madali sila patong-patong at maging crystalline solid. So therefore, they will have a stronger lattice, crystal lattice. They will have a higher melting point. How about sa letter C, Josh? Bakit si acetic acid ang mas mataas ang melting point versus kay sodium acetate? Bakit mas mataas ang boiling point ni acetic acid versus sodium acetate?
Hydrogen bonding.
Ha?
Hydrogen bond.
So, ibig sabihin yung ano, sige, tama naman. This one has hydrogen bonding. Ano ba yung sa sodium acetate? Ano yung nag-e-exist sa sodium acetate?
Sa ano naman po, polar naman. Bipole lang.
Hoy, hindi dipole-dipole lang sa sodium acetate.
Ionic.
Correct. Naku,
Okay,
ayan.
okay.
Ganito. Ano to, si acetate, negative to. Si sodium mo, positive. So therefore, ano to, ionic. So sino mas stronger, ionic interaction or hydrogen bonding? Yes, Josh, which one is a stronger IMFA? Ionic interactions, hydrogen bonding. So ito yung mga pinaka malalakas mong ano, no? Intermolecular forces of attraction.
Sa ionic.
Okay. So dapat ito yung higher melting point. Siya yung tamang sagot talaga. Higher MP. Okay. So with that, clear ko lang yung lahat ng drawings. We'll now proceed with the next one. No? Wait lang, Josh, very fast. The next property will be solubility. Wait lang po. Okay, so we now have the next property that we will discuss, physical property that we can predict, no, using the IMFA will be solubility. So when you say solubility, it's the extent to which a compound called a solute dissolves in a liquid called a solvent, or basically, may meaning talaga tayo ng solubility, no? Solubility is the amount of solute that can be dissolved in a given solvent, no? Or yung ano niya talaga, strict definition, how much solute can be dissolved in 100 grams of solvent, no? Kunwari may 100 grams kang tubig, gaano kadami yung madidissolve na solute? So ngayon uh, there's a there's a correlation, no, for the solubility and intermolecular forces of attraction. So the energy needed to break up the interactions between the molecules or ions of the solute comes from their new interactions between the solute and the solvent. So tingnan mo to, Josh, ha? Yung solute kasi, yung solute sa solute, meron siyang interactions talaga. Pero once you have the solute now will have a an interaction with your solvent. So this new solute-solvent interactions um, will make your solute stable in that medium or in the given solvent. So energy comes from the new interactions of the solute with the solvent. No? So it's pretty clear here that hindi naman basta-basta matutunaw kagad, Josh, yung ano yung solute mo, no? So kapag ang solute-solute interaction kasi, Josh, ay sobrang strong, no? You cannot easily separate them. So therefore, they will be insoluble, no, in your given solvent. Pero kapag weaker yung solute-solute interaction mo, therefore they can form, no, they can form a new, stronger solute-solvent interaction, mas natutunaw ngayon siya. So it depends on the nature of your solute. So kailangan mo ngayon tignan yung um, nature ng solute mo. So this is the general trends no for solubility. So ano ba yung mga trends natin sa solubility? So babalik ka ulit Josh dun sa factors affecting solubility. But this time organic compounds yung tinitignan natin. So organic compounds pala yung tinitignan natin dito, Josh. Kasi nga organic chemistry tayo no. So dito tayo ngayon naka-focus. So ang first rule natin ay yung nature ng solute mo. Compounds dissolved in solvents, yes.
Technically po, kung let's say I have, yung ano po, diba, yung naglagay ako ng emulsifier.
Okay.
So, nandun na yung mga particles. Ngayon, tatanggal ko pa yung emulsifier using something. Kasi mag-magnet.
They will separate. Tapos boom, ang laki nung non-polar head mo. No? So, it's very difficult talaga for the hydroxy group to solubilize cholesterol sa water kasi ang laki-laki nung non-polar part mo. So, you have a very large hydrophobic region or hydrophobic part for cholesterol. So, the polar part of a molecule that can do hydrogen bonding with water is known as hydrophilic regions or hydrophobic part or hydrophobic functionality. So in cholesterol, for example, the hydroxy group is hydrophilic, while the rest of your carbon skeleton will be hydrophobic. So I think ito na yung summary sa solubility rules no ng organic compound. So solubility properties of representative compound. So kapag ang IMF mo ay ionic, so ion sa ion, so soluble sila usually sa water. Tapos kapag sa inorganic solvent, insoluble yan sila. So, what if you have a covalent compound? So, let's say BDW lang, no? Or London dispersion forces like butane. So, butane, since ano lang ito, BDW lang, no? Insoluble siya sa water because you don't have any nitrogen or oxygen atom to hydrogen bond with water. However, this time, it's soluble in organic solvents such as CCl4 or carbon tetrachloride. How about your alcohol na propanol, no? Propanol. Propanol is soluble still, no? Still soluble in water because your alcohol group belongs to a 3 carbon atom lang. So, it's less than 5, no? Sabi ko nga sa iyo, ang boundary para masabi mong soluble or insoluble ang isang organic compound, 5 carbon atoms, no? So, dahil tatlo lang naman yung carbon atoms mo, tapos alcohol pa yan, you have a hydroxy group, that oxygen atom in your alcohol can do hydrogen bonding with water. So, soluble yan sa water. Since si propanol ay may propane part or propyl part rather, so you still have a carbon skeleton there, it's still soluble as well in CCl4. So, ang maganda sa CCl4, both polar and non-polar organic compounds are usually soluble in CCl4. Okay? So, kasi nga may organic functionalities ka or meron kang alkyl group. Ngayon, same pa rin. May alcohol ka, but this time, 10 long chain to, no? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then, OH. Decanol. So, you have decanol here. So, decanol contains an OH group. However, it's greater than 5 carbon atoms, no? Since you have greater than 5 carbon atoms, the tail or the alcohol the carbon skeleton chain is too large to be soluble in water even though it has an oxygen atom for hydrogen bonding with water no present in your hydroxy group. So, however, si decanol soluble pa rin siya sa organic solvent. Okay, so yan ulit Josh. Okay. Yan muna tayo. Which compounds are soluble sa number 1 Josh? Ito yung number 1 mo. Which compounds are water soluble? So meron kang 5 compounds dyan. Bibilugan mo lang kung sino yung water soluble. So number 2, Josh, which of the following molecules can hydrogen bond to another molecule like itself? And then the next question, with water. Okay? So again, which of the following molecules can hydrogen bond to another molecule like itself and then with water? Yan lang muna. Sige, I'll give you a minute for this. Yan, para sagutan mo siya. 1 minuto lang ha. May answer ka na, Josh? How about sa number 2? Sino daw yung compound na kayang makipag-hydrogen bond sa sarili niya? At sino naman yung compound na kayang makipag-bond sa water? Dalawa yung sagot mo sa 2. Hindi, ang lagay mo, Josh, ay hydrogen bond with itself, hydrogen bond with water. Or pwedeng dalawa sila, Josh. Kaya niya makipag-hydrogen bond sa sarili niya at makipag-hydrogen bond sa water. So, Josh, yung diethyl ether, it can hydrogen bond with water. Yeah. I mean, the diethyl ether can also hydrogen bond with itself, right? That's your answer? Okay, sige. Yan, mukhang ano ka naman na. May answer ka na. So, okay, tatanungin kita sa number 1. Bakit meron kang yung mga broken lines na circle?
They are
Broken
slightly
circle.
soluble. I know po na they are slightly soluble, but
Slightly
they are not.
soluble. Okay, sige. Why is chlorocyclopentane soluble in water? Why did you choose chlorocyclopentane?
Because it is chloro. May chloro po siya. Tapos
So yung
ano,
chlorine enough yun for you to say that the chlorocyclopentane is soluble in water?
yes, I would say po it's enough.
Mhm. Okay. Sige. Puntahan mo yung cyclopentanol so that you can have a much more realization. Sige, sure tayo sa cyclopentanol, di ba? This is soluble in water, right?
Opo.
Kasi 5 carbon atoms tapos naka-OH siya. If you will notice, Josh, si chlorocyclopentane mo kasi, that's correct naman, no? Si chlorine ba, kaya mag-hydrogen bond with water?
Yes.
Yeah, that's true, no? However, kung makikita mo kasi, yung chlorocyclopentane dito, yung ring na to, this is a very hydrophobic ring. So, hydrophobic ring. It's large enough, no, compared to your chlorine atom. In fact, chlorocyclopentane is insoluble, Josh, in water.
Chloro?
No? Yes, chlorocyclopentane.
I'm pretty sure I've seen po si Nile Red, meron po siyang soluble. Di ba?
Chlorocyclopentane. Insoluble yan sa tubig. Pero we can say, yung solubility niya, compared to other organic compounds, mas mataas kasi may chlorine ka pa naman eh. Pero, alam ko ano yan, insoluble yan. Kahit nga alam ko sa lab, insoluble yan eh, sa tubig. Masyadong nakaring kasi. Kung naka-open chain pa yan, parang matatanggap ko pa. Pero kapag nakaring, ay mahirap ah, mhm. Pero we can check. Yeah, chlorocyclopropane is insoluble. Uh, chlorocyclopentane is insoluble in water. Very low. Low solubility. However, si cyclopentanol, sure tayo soluble yan. Oh, defend your answer here. Why is diethyl ether letter C and that's butyl, tributylamine is slightly soluble in water? Si CNE, Josh. Yes, Josh, si CNE, bakit kaya?
Si C po, ni ether po siya eh. So, it must be at least slightly water, slightly soluble in
Ganito yan,
water.
di ba? Diethyl ether yan eh. 1, 2, eto. Ganyan. Right?
Tsaka di ba na po siya in suspension with water na parang slightly soluble na po siya para sa ano po, topical anesthetic.
Actually, si diethyl ether, di siya slightly soluble in water. Insoluble talaga siya. Nagsiseparate yan eh. So, tsaka yung oxygen atom mo, trap yan, no? Trap siya. Pero tama ka ha, it can hydrogen bond with water. Ito nga yan eh, ayan no? It can hydrogen bond with water. This is correct. Pero Josh, yan, itatama ko na tong number 2 mo. Diethyl ether cannot hydrogen bond with itself. If you want, sige nga, can you show me how can diethyl ether hydrogen bond with itself? Saang hydrogen atom ni nung kapitbahay na diethyl ether kakabit dun sa oxygen, di ba? Wala. Kasi CH3, no, hindi. Abomination yan. Metal group yan eh. Your hydrogen must be bonded dun sa highly electronegative element. Isa ding reason yun kung bakit si chlorocyclopentane, Josh, hindi siya soluble. Hindi kasi din kaya ni chlorocyclopentane mag-hydrogen bond with itself because you don't have hydrogen that can bond with chlorine. No? So, yeah. How about si ano? Tri tributyl tributylamine. Parang ganito yan, Josh. Nitrogen, tapos ganito yan, no, ang haba ng flow. 1, 2, 3, 4. 1, 2, 3, 4. Ganyan yan, Josh. 1, 2, 3, 4. This is butylamine. Nakikita mo yung drawing ko, Josh. Yung parang octopus. Ayan, ganyan siya, Josh. Will you expect that soluble in water? And how many carbon atoms yan? How many carbon atoms na yan, Josh? For tributylamine. Yes, Josh, how many carbon atoms na yan?
Ah, 8?
Hoy, anong 8? Hindi lang 8 yan.
Nasabi mo?
Tributyl eh. Tributylamine.
Tatlo. 12.
12, di ba? Ang laki masyado niyan. So, you have a very big molecule. So, therefore, letter E is also insoluble. So, sure naman tayo insoluble to. Sige, partially soluble. Pero more on leading to insolubility. C diethyl ether. Joshua, please take note, diethyl ether cannot hydrogen bond with itself. But diethylamine, since may hydrogen ka pang naka-attach sa nitrogen, it can hydrogen bond with water and can hydrogen bond with itself. Very good. Don't worry, hindi naman to hindi naman to practice set pa, no? So sa practice set tayo sasabihan kita kung tama na final answer na ba yan. Eto dito, kino-correct pa lang din kita kung mali yung concept mo. Okay, next. Dito, Josh, lalagyan mo lang ano yung mga hydrophobic at hydrophilic part. So I've given you 3 molecules. The first one is norethindrone. It's an oral contraceptive component. The second one is arachidonic acid, which is a fatty acid. Then the third one is benzoapyrene, a derivative, benzoapyrene derivative rather. It's actually a carcinogenic component derived from tobacco smoke. Go ahead, bilugan mo, Josh, yung mga, ganito na lang, kulay red kapag polar group or hydrophilic, kulay red. So, asan na yun? Joshua, red kapag hydrophilic, then blue kapag hydrophobic. Yan, change natin yung color ko muna. Blue naman kapag hydrophobic. Sige, go ahead, Josh. So, tatlo yung molecule mo ha. I'll give you 1 minute for this lang din. Indicate the hydrophobic and hydrophilic regions for the following molecules. Norethindrone, benzoapyrene derivative, and arachidonic acid.
Arachidonic acid?
Yeah, arachidonic acid is C20. Alam ko, ay C20 ba yun? C24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Who decided to name it like that?
Yeah, it's 20. Arachidonic. Alam ko nga, 20 yan eh. Kasi yung si arachidonic acid, ano yan eh, magiging precursor siya ng maraming non-polar molecules sa katawan, including cholesterol, if I'm not mistaken.
Bakit pala binigay ko? Bakit kamukha na po na to si testosterone? Steroid din po yata siya. No?
Yeah.
Yan, fully ano na po siya.
Okay. O ba? You're good?
Opo.
Nice. You're good?
Opo.
Very good. This is really good. Alam mo kung sabi ko nga kung maayos kasi yung Gen Chem mo, tapos concept mo with the polarity, intermolecular forces, sobrang dali na lang nito sa'yo. So, good. For no, norethindrone, you only have the hydroxyl group and the ketone group, no? That is polar. Then the rest will be non-polar. So those will be the hydrophilic sites, the red ones, and then the blue ones will be the hydrophobic. Very good. Benzoapyrene will have three polar sites, but you'll have a very big, no? A very big na um, non-polar group. By the way, Josh, just a question. Madali si B. Si carboxylic lang talaga yung polar group niya. Then the tail will be non-polar. What do you think is the solubility of A in water? Soluble or insoluble? Kaya A muna.
Soluble.
Again, sinorethindrone, soluble, insoluble?
Insoluble. Masyado po marami
Yes,
yun.
correct. Masyadong malaki yan. Very good. How about si benzoapyrene?
Still insoluble. Or
Very
baka
good.
insoluble.
Insoluble talaga yan yung si benzoapyrene. Yan yung parang latak nga yun sa pag nag-ano ka eh. Nagluluto, nag-iihaw. Very insoluble. How about arachidonic acid?
Insoluble po.
Yeah. This is also insoluble kasi nga 20 atoms, no? 20 carbon atoms and you only have 1 carboxylic acid. So definitely, insoluble siya. Okay, so the next one will be reactions na, no? Um, reactions involving functionalities. Oh, don't worry, no? So hopefully within 30 minutes we're done already. So, patapos naman na tayo. Slide 162 na versus 167. Yes.
Baka
So
po
it means
yes.
Josh. It means Josh, you'll have so next
Ako
meeting
na
you'll have
po. Ako na
we'll have your
Pero
favorite.
hindi ko pwede sabihin yung word.
Okay, later. I'll mention it later. So the next one will be functionalities and functional groups acting as electrophile and nucleophile. Na-mention ko na sa ulit to eh. Ano nga ulit yung nucleophile? I-define mo lang ulit. Electron poor or electron rich region? Ang nucleophile, nucleophile.
Nucleophile is electron rich.
Very good. Most of the time, kung acid-base yun, ano siya? Acid or base? Ang mga
Ah,
nucleophiles.
wala. Donator. Electron rich. So, sabihin siya yung base.
Very good! Correct. Lewis bases yung mga yan, no? Kahit Bronsted-Lowry base din, pwede rin. So, similarly, ganun din sa mga electrophile mo. Electrophilic regions are also your Lewis acids because they are electron poor naman, no? So, electron poor. Kaya nga electrophile sila. So, ngayon, all functional groups contain a heteroatom, a pi bond, or both. So, they can be site for your organic reactions. So these features create electrophilic sites and nucleophilic sites in a molecule. Josh, very important to understand that once you have a heteroatom or a multiple bond, so containing a pi bond, no? Or pwede ring both, site yan ng organic reaction, no? So, let's say electron-rich sites, which are nucleophiles, react with electron-poor sites, which are electrophiles. Which is, ginawa natin siya previously, no? Doon sa Lewis acid, Bronsted-Lowry base natin, Bronsted-Lowry definition, sa Lewis definition. We also do curve arrow pushing or curve arrow notation, no? So, when you have an electronegative heteroatom like nitrogen, oxygen, or X or halogen, no? It makes your carbon atom electrophilic as shown below. So, we can clearly see here, Josh, no? So, itong chlorine mo, dahil electronegative yan, this will be partially negative. Making this carbon, yung directly attached sa kanya, Josh, ha? Please take note, Josh. Directly attached kay chlorine, partially positive. So, this one will be an electrophilic site kasi electron poor yan. Similarly, with cyclohexanol, yung carbon directly attached to your hydroxy group is partially positive this time, no? So it's also an electrophilic site. So next, how about the nucleophilic sites in molecules? So a lone pair, so ano-ano yung mga nucleophilic site mo, no? A lone pair on a heteroatom makes it basic and therefore it's a nucleophilic site. So, example for ethers, si oxygen atom sa ethers, dahil may lone pair ka, basic yan and nucleophilic site. Sa mga amines naman, yung lone pair ni nitrogen makes your amines basic and nucleophilic. Can you think of other functional groups, Josh, na basic? Aside from ether and amines? Sige nga, Josh. Lewis base. Isip ka ng functionality pa, functional group na pwedeng nucleophilic site.
Amides po. Oo.
Again?
Amides.
Correct. Tama naman, no? Amides. Or pwede rin naman yung carbonyl group. Yung oxygen doon sa carbonyl group is nucleophilic site din, no? It can act as a base. Meron pa, yung multiple bonds mo. So sa multiple bonds nga ulit, Josh, sino yung madaling ibigay na bond? Kunwari may double bond ako, Josh. Sino yung nababaling bond? Tapos eventually ibibigay mo yung electrons na yon. Kasi ano sila eh, nucleophilic site eh. Ang mga multiple bonds ay electron-rich regions because bonds are made up by electrons. So therefore, we can give them, no? Or they can act as donors, yung mga multiple bond compounds mo. Sino ang napuputol nga ulit? Anong electrons yung binibigay mo kung yung multiple bonds mag-act as nucleophilic substance? Yes, Josh?
Ito po lang. Good question.
Yung pi bonds, no? So 'di ba, yung pi bonds kasi mabilis siyang maputol kasi nga sideways overlap naman lang siya. So the pi electrons are usually donated, no? Papunta dun sa electron pore site mo. So therefore, yung mga multiple bonds, they are acting as nucleophiles as well. So ngayon, we can now have reaction of pi bonds with electrophiles, no? So let's say you have an electron-rich carbon reacts with an electrophile symbolized as E. So usually we symbolize electrophiles as E plus. Matik yan, Josh. If you will see a capital E with positive sa organic books, electrophile yan, no? What happened? Ayan, electrophile siya. So for example, alkenes containing electron-rich double bond, they react with electrophiles. Ang tawag dito ay electrophilic addition. So this reaction mamimit mo ito ulit sa alkene. So itong double bond mo, Josh, dahil ito ay electron-rich, therefore nucleophile siya. This pi bond here, the pi electrons can be donated papunta dun sa electrophile mo, which is an electron poor region. So katulad nito, pwede rin yung ganito naman, no? Alkyl halides possess an electrophilic carbon atom, so partial positive. So they react with electron-rich nucleophiles such as this one. So usually ang electron-rich nucleophile ay mga bases. So, let's say strong bases, no? Strong bases. So, yung strong bases mo, dahil may lone pair ka, Josh, pakitandaan, yung arrow pushing mo, start ka sa electrons mo, aatakihin niya, it will attack the partially positive side or the electrophilic side para magkaroon ka ng bond. Okay? Okay. Sige. Last na item for today. This is our last item for today, no? For number 1, label the electrophilic and nucleophilic sites in each molecule. So, lagyan mo lang yung ito, electrophilic, ito, EN. So, lagyan mo lang ng E and then N. So, kapag merong lone pair, Josh, identify mo yung lone pair kasi wala lang lone pair dyan. Electrophilic site, then N. So, kung walang mga partial positive, partial negative, lagyan mo din para at least alam natin electrophilic or nucleophilic region yun. That's for number 1. So, number 2, considering the electron density, state whether the following reactions will occur. So, sasabihin mo lang kung mag-a-occur ba yung reaction or not, no? So, kasi baka yung iba, hindi siya possible talaga. Sige, go ahead. I'll give you 2-3 minutes for this, I guess, para at least ma-discuss na natin yung sagot. Yeah. Sige, labelan mo sa number 1, ano yung mga electrophilic and nucleophilic sites. Sa number 2, predict the reaction. So sa number 2, pwedeng may sagot dyan na NR. I don't know, no? Kasi baka hindi niya kayang palitan, no? Or baka wala talagang mangyaring reaction. So we'll see. ba? Kaya asan yung mga electrophilic sites mo? Kaya sa number 2, Josh, ha? Predict the reaction. And if there's a reaction, you try to predict the product. Josh, ang nucleophilic and electrophilic sites, atom yun usually. Not a whole thing. Lalo na yan, no? Atom sila usually. Tsaka yung water, hindi mo nilagyan ng electrophilic site. Usually atom yan.
Itong band mo.
Yung band, tama yun, tama. Lalagyan mo siya ng um, arrow. Tama naman siya. Yung water din ha. Naku, grabe yung ano, ang dami mong electrophilic site. Sige, mamaya anuhin natin yan. Check natin. Yes, ang meaning ng electrophilic site, partially positive ang carbon. Okay, what about the number 2?
Ilan mo?
O sa number 2 ha, show also your ano, um, curve arrow notation or arrow pushing.
So, ano ba 'to?
Excuse po.
Hmm.
Yes, Josh? Okay. So, let's check number 1 muna.
Tignan mo.
Che-checkan lang natin number 1.
Hindi mo
For
mo
1A,
hindi ako patapos.
for 1, hindi ka pa rin tapos?
Hindi mo.
Sige, go ahead. So, para at least we can you can be you can go now with your swimming kasi baka magabi kayo, Josh.
Must be motor ito.
Yes, are we good with number 1?
File.
Please tell me, Josh, if you're done, ha? So that we can check 1 and 2.
Sige po, check mo.
You're done with 1? Oh, yes. Okay, mag-arrow pushing ka. Where's your arrow pushing? Good for A. How about for B? Okay, how about B? Grabe yung bromine. Tingnan mo ha. Is that possible? Bromine is electron rich. The multiple bond is also electron rich. Di ba? Oh. They are both electron rich, Josh. The bromide ion and the multiple bond, yung triple bond mo.
Pili ka
They
po
are
sa
both
mag-word.
electron rich. So do you
Pili
think they will react?
ka po sa mag-word.
in every organic reaction, you should have an electrophile and nucleophile. That's your clue. Okay, no. Good. About number 3. Mhm. No, oxygen is electron rich.
Pag
Methoxide is also electron rich. You cannot react it with oxygen. Very good.
okay.
Sa
So,
electrophilic carbon yan. Good. Ayan, si letter D. O, baliktad. Bromine plus yan. Bromine plus. You
parang
start with the
parang I will treat it as a
you start with the bond because no, not the carbon atom, the bond itself because yan, there you go. So a bond will be broken. Sige. Go ahead. You draw the structure. Actually, you can use that one na oh. Yung pwede mo na gamitin diyan Josh yung mga ano na eh, skeletal eh. Pero ikaw bahala. Sige. Yeah. That's correct. O, tignan mo, nag-double bond na lang, hindi na dapat straight lang yan, no? So, dapat nga pag ano na siya, oh, yung 120. Na-conscious.
wallet.
Okay, good. Oh, there's a charge there, right?
Okay. So,
No, not bromine. Bromine is complete already. It's octet
it
already.
kind of
Okay, good. Dun sa kabilang side, no? That makes your that makes the other carbon electrophilic this time. So it can undergo another reaction. It can undergo another reaction. That is how we do mechanism. Naku, pag nag-start na tayo sa mechanism, matutuwa ka. Kasi nagpo-propose ka minsan ng mechanism, possible mechanism, why a reaction is happening. Anyway, let's start with number 1. So letter A. So this one is correct. So partially positive ito. So this is an electrophilic site, this one. Check. Ito is nucleophilic. So, bromo cyclohexane, no? This is correct. In water, hydrogen is your electrophilic site. Oxygen is your nucleophilic site. This is also correct. And then, Josh, sa letter C, nucleophilic site mo lang, yung ito. Wala to. You don't have an electrophilic site there actually. So, you only have a nucleophilic site, your double bond. No? Josh, ha, paki-remember to ha. Your multiple bonds, the carbons there are not electrophilic generally. The bond itself is nucleophilic because it's electron rich. So ito lang, tama na to yung multiple bond lang. Then for letter D, this is correct kasi meron kang lone pair dapat dito, nilagyan mo ng lone pair yung nitrogen at saka yung bond itself. Those are your nucleophilic sites. However, may electrophilic site dapat dito, Josh. Ito nakalimutan mo, oh. Tong carbon na to, this is partially positive because it's bonded to nitrogen. Imine nga yata to if I'm not mistaken. C double bond N. No? Carbon doubly bonded with nitrogen. I think it's an imine. So, yeah, partially positive yan. No? Actually, this methyl group here, Josh, it's also partially positive. this makes your two sites, these two carbon atoms, electrophilic sites, no? So, yeah, that's letter number 1. For letter A naman, this is correct. So, this hydroxyl group here, or hydroxy group, the OH hydroxide, can react with partially positive CH2 so that bromine will be given off, no? So, dapat plus Br minus. Yan. Kulang ka, Josh, ha? Uy, Josh, don't forget the ano, ha? Don't forget the byproducts. So, sa letter B, it's not possible because both of them are electron-rich. So, there are
Why is
both
it not
electron.
possible? Why is it impossible?
You don't have an electrophilic site at all. So, if you don't have an electrophilic site, no reaction will happen kasi dalawa silang electron-rich. Eh. They are both nucleophiles. Nucleophiles can't react with one another.
Kailangan
So,
pa ng kailangan mo pa ng electrophilic substance
yes.
for ano po for
Or,
some
pwedeng ganito, Josh. Your bromide can be a secondary agent. Make first your alkyne an electrophilic alkyne. So let's say kunwari tanggalin mo tong CH3, you remove the CH3 so this one will become positive and then add the bromide ion so that you can have the bromine atom attached to your alkyne, directly attached to your alkyne, no? So that's a good functionalization. So when you say functionalization, you're changing the functional groups, no, in a given molecule. So this is also correct. Actually, Josh, no, nag-i-start na tayo mag-mechanism ng mga reactions. So, the methoxide can actually attack. So, when you say attack, electrophilic, no? Electrophilic attack of methoxide to this carbon because this is partially positive. This is a carbonyl group. And then this chlorine can now leave. So, dapat may Cl minus. So, don't forget ha, don't forget the byproducts, Josh. Very important. Then for letter D, this is correct. From the bond itself, diretso lang attack kay electrophilic attack kay bromine plus or bromine positive. And then you'll have this product. Okay, so I think we're good. So on Thursday, Josh, please expect that we will start. I'll stop sharing na. Please expect that we will start your favorite your favorite section um for every chapter that we'll have. Anong
po ay
pinaka-favorite mo?
it's really my favorite. I like it. It's my favorite part of my favorite.
We'll now be entering the very first organic concentration camp. So we'll have the
Ano
very first
ano po,
organic
back
training camp.
back to office.
Training camp naman siya, training camp.
Ano
Okay?
po,
So,
re-education camp lang po.
what?
Totally na. Concentration camp po, re-education camp lang.
Hmm. Organic training camp. So first, ano no. So please wait. I'll be posting later this night your first problem set no sa organic. Pero mahaba-haba yun, Josh, because actually no, in reality, we already covered 3 chapters as part of the introduction for organic chemistry. Okay? So I think you can now prepare for your swimming classes. Enjoy the rest of the day, Josh, ha? And be careful with your swimming, ha? Regards to your dad as well. Okay? See you on Thursday.
Yan ang po. Bye-bye.
Yeah, ingat.